Okay, so for question number 1, we've got a truck that is going to be coasting to a stop. Excuse me. If we're coasting to a stop, what's stopping us? Friction. Okay, it's a level road. There's no incline. There's no F parallel to work against or anything like that. Only friction is bringing the vehicle to a stop. Right. So if we're looking at the free body diagram here, the only important force is the force of friction. Right? It's what we're looking for because we're trying to find the coefficient of friction. We have to have the force of friction before we can do that. The other thing we need, if we're going to find the coefficient of friction, is the normal force. Since this is a level road, normal force will be equal to gravity. Okay, so we can calculate that as well. All right, so we have an 8,000 kilogram truck. Okay, the rest of our givens are that VI is 28 meters per second. Okay, that VF is 0 meters per second, and that the distance traveled is 140 meters. So mark for givens there. Okay, our next mark will be for calculating the normal force. So M times G, so that'll be 8,000 times 9.81. Okay, so we've got 78,480 newtons. Okay, so they can have a mark for that as well. All right, what can I calculate right now with the velocity and distance information? I can calculate acceleration. Why is that going to be important? For finding F net, okay? And F net is going to equal this force because it's the only one that's not balanced, okay? So I'm going to find the acceleration, okay? And I'm going to use VF squared minus VI squared over 2D in order to do that, okay? So we'll have 0 squared minus 28 squared divided by 2 times 140. Okay? So they can have a mark for their answer here. Okay, so they actually have to get the right number for the acceleration here to get this mark. So we will have 28 squared divided by 280. Okay, so it's going to be 2.8 meters per second squared, and that's going to be negative. Okay, because it's backwards. They don't have to have the negative on there at this point to get that mark, okay, but they have to have 2.8 meters per second squared. Okay, now that I have that and we're up to 3 marks, I want to calculate my net force. Okay, so friction is equal to net force, which is equal to M times A. Okay, so they can have a mark if they'd said something like that. Okay, and so that'll be 2.8 times 8,000 kilograms. All right, so we're looking at 22,400 newtons. And that's backwards, not that it matters for this, okay? The negative really isn't important for what we're doing here, right? And then we're going to calculate the coefficient of friction. So the force of friction equals mu times the normal force. So to get mu, we're going to have force of friction divided by normal force. Okay, so that'll be 22,400 newtons divided by our 78,480 newtons worth of friction. Yes, divided by our normal force. Okay, so we've got those two numbers there. Okay, so our coefficient of friction is 0.285. We have 2 significant figures, so it's 0.29. Fifth and final mark. Okay, no units on that. Okay, remember, I divided newtons by newtons in order to get that number. Okay, questions on number 1? All right. Okay, question number 2. Got an inclined plane. It's 38 degrees, so it's pretty steep. Okay, we have this box that's 20 kilograms being pulled up the ramp by a rope. Okay, at a constant speed of 1.5 meters per second. So that's going to be a crucial piece of information. I know that the force of friction is 80 newtons, and since it's moving up the ramp, friction is acting down the ramp. What other force is acting down the ramp? F parallel. There's their givens, 1 mark for that. Okay. Next thing I've got to calculate is the force of gravity because I need it for my internal triangle. So force of gravity, okay, here I've got force normal, which I won't need for this question, and I've got F parallel here. This is a 38-degree angle. Okay, force of gravity is going to be 196.2 newtons. Right, so if they have that, they can get a mark for that, calculating the force of gravity. Okay, their next mark is for calculating F parallel. That'll be the sine of 38 times 196.2. Okay, so we got 120.79 as our force parallel. 20.79. Okay, 1 mark for calculating that, and I'll take that as a method mark. They don't have to have got the right answer for that. Okay, so if I am looking for the force applied, or the tension in the rope, force applied plus F parallel plus the force of friction equals the net force, which is 0. Yeah, that's fine. Okay, so that's what we've got. Okay, we're looking for F net. F net is 0. So if I'm going to find the applied force, really all I'm doing is adding those two numbers together. The forces up the ramp are equal to the forces down the ramp. Everybody okay with that? Okay, so force applied then, okay, so if they've got something like this, or they have F net equals 0, okay, I'll accept that. That's their sum of all forces calculation, which is a necessary step in this. That's the 4th mark. Okay, our applied force then will be 200 newtons, right? We only have 2, no, we have 3 significant figures, so we'll have 201 newtons as our applied force. 5th and final mark. Okay, questions on that one? All right.